Okay. Hi, hello, good evening, good morning. My name is Shantanu, and I'm a part of the developer relations team at Hemera. Today with me, I have Alan from Verax and Linea. So we are here today to talk more about Hemera and Verax, and talk more about account-centric indexing from the Hemera side. And Alan will be throwing more light on attestation and all of those aspects. We'll be also doing like a very good comprehensive code walkthrough, wherein we'll be walking you through on how to set up your own UDFs on Hemera and how do you create your own attestations on Verax. So Alan, over to you. Do you want to take up the introduction and then we can kick start?
Um, yeah. Um, so hi everyone. My name is Alain. I'm working at Consensus. Consensus is the company behind MetaMask and Linea, for example. And I'm a contributor to Verax. Verax is an attestation registry, and we'll have the opportunity to dive into that just after.
Awesome. Perfect. So I think I'll get started with what Hemera is, do a very basic walkthrough of how do you create your own UDFs, how do you run your own indexer using Hemera, and then I'll hand it over to you. Perfect. So yeah, let's first talk about what Hemera is and why did we start building Hemera. So yeah, first things first, there are a couple of challenges when we talk about data in general in Web3. So one being, if you're trying to integrate AI with Web3 data, that comes with a lot of challenges. So as you know, AI requires a lot of user-centric data. I mean, if I am a user and I want to know more about my details, I need a more personified and more user-centric data. So, and blockchain in general has like a lot of set of data that is, I mean, that is stored and that is cluttered around. So lack of infrastructure for all of these data retrievals can become a problem down the line. So that's how, so that is bigger the problem. And that is the problem that Hemera is trying to solve using account-centric indexing, which is ACI. So if you look at the current issues in the crypto ecosystem, one major issues is there are new blockchains, new L1, L2s popping out, and there is a huge plethora of data that is out there. So correlating all of these data together can be a very big problem and a challenge as well. And for dApp developers, the biggest challenge that they usually face is getting the on-chain profile. So the very recent trend about Farcaster, right? So Farcaster had given access to people to the whole social commerce and social graph ecosystem, and they built everything on-chain. So that's the beauty, right? And the other side is if somebody wants to access the on-chain profiles, or let's say if I have a wallet which is shantanu.eth, so I want to access all of my transactions, I want to collate them. So that becomes a very big problem at this point in time. And that's how Hemera is trying to solve by creating account-centric index. And moving next, let's throw some light on ACI network. And so essentially Hemera, we have introduced a programmable and more portable Web3 data network, wherein it essentially abstracts the low-level data structures and the smart contracts. And we have a UDF, which is user-defined functions, which are triggers that runs across with the indexes that we host. And you can chunk out the data, personalized data that we want. So we'll be talking more about UDFs. We'll be actually exploring UDFs and how do you create your own custom UDFs for different sort of chains. So let's dive a little deep into what ACI is and how does it essentially works. So ACI focuses more on the on-chain profilings and it updates in real time. Second is you can categorize the accounts based on transaction balances, histories, NFTs, and there are a lot more categorizations that you can do on what basis you want to categorize your account. There are features that you can update using UDFs. So for example, that I am a user and I want to know the mints, different set of mints happened for a particular ERC712 token. So I can write my own custom UDF. I can run it across with the indexer that I have. And all of these data can be easily extracted. Second stuff is it allows developers to define and share new features within the network. So making it more decentralized, making it more user-friendly. So people can build their own set of rules and use others' UDFs as well. Why account-centric? So the bigger question happens here is, one, it simplifies the whole computation part. So you don't have to run the whole Genesis, whole indexer or run your own Genesis node from scratch. because it comes with a very heavy cost. If you want to run if you want to retrieve your data, if you want to run a Genesis node, it comes with a cost. And let's first say if you're using a centralized API, you never know when the API goes down, right? So it's always better to have your own control over the data that you want to index or you want to retrieve. So that's the best feature about using Hemera. And moving next, let's talk more about some use cases that you can build using ACI. These are some use cases. There are many more use cases that you can build using Hemera's ACI network. One is real-time access to on-chain activities. So one of the examples is the social scan product that we built out internally, wherein we showcase the power of ACI network, we showcase the power of UDFs, and you can easily retrieve data, you can play with on-chain agents, and there are a lot of exciting things that happen on the social scan product. So it's you can use it as well. I'll drop the link in the description. It's socialscan.io. But yeah, you can sign up, you can play along with the with the whole ACI network that is powering social scan. Second is understanding user activities. So if I have an on-chain profile, which is on Farcaster, if I want to understand all of my detailed understanding of who follows me and what are the follower recommendations that Farcaster can give out to me, or let's first say what are the meme coins that I've interacted in the past 6 months. So these are some basic on-chain profiling activities that you can extract out of it. Next is there are few more future development that we are planning to do. One is making it more modular. Already the team is building on some really exciting cool stuff. So one is we are trying to make it more modular and working on making it more horizontal scale. So Hemera's ecosystem is quite large. So we have been supporting a lot of block explorers, a lot of L1 and L2s to build out their own block explorers. There are some AI-driven services also that we are helping out giving, and there are a few exciting partners. So we have been building out block explorers for Tycho, Linea as well, and Cyber, Morphin, to name a few. So to get started with Hemera, essentially what I would recommend is to go to the docs for a developer, and for a product-oriented person, it's always better to browse the website, understand how the product works, and then explore more. So if you're building on Hemera, so the first step that I would recommend is go to the docs, explore how the documentation would look like. And then there is a new release that we did that I'll be showcasing on how to run your own indexer network. And then finally, if you want to explore more about the social agents that we have, you can explore the social scan. And please don't forget to hit a follow on the socials if you are active. Perfect. So I'll quickly share my screen and I'll showcase you the second. Perfect. I hope my screen is visible. Yeah, perfect. So to get started with the Hemera indexer or the ACI network, what I essentially recommend is to clone this repository, which is Hemera-indexer. And in the entire repository, you can see there are multiple sort of files that makes the computation quite easy. So to run this whole set of things, you need a couple of you need either a Linux machine or a Mac machine. I would recommend using a Linux machine. It's as simple as running your own Docker image. So if you're familiar with Docker, if you're familiar with all of the Docker Compose commands, so all you need to do is clone this repository. Just get into the Docker Compose folder. You just need to get into Docker Compose folder. Edit the Hemera-indexer env file, which contains all the essential environmental variables. So it will quickly explore what all variables we have here. So first things first, we need to provide the RPC URL. So based on the chain that you want to index, so let's first say you want to index Linea, or you want to index any other chain. Let's first say Ethereum as well. So all you have to do is provide your RPC URL here, the start block. From the block where you want to start fetching the data, you can mention that. I always recommend to provide like a 3 months gap or a 2 months gap based 2 months before block, because if you start from Genesis, it's going to take a lot of time. So it's always better to start with the latest or with a little bit of history. And next is Postgres. So if you want to chunk out your own output, all of the output into a Postgres DB, or else if you want to chunk it out into a CSV file or a JSON, these are the 3 native supporting things that we support as of now. So you can easily mention them in the output variable. Let's first say I want to do it for specifically for Postgres. I can do this. Or if I just mention CSV here, so all of my data will be dumped into a CSV, which will be natively available on my local drive, and I can access all of my data right there. So, but for this example, I'm trying to use Postgres, and I've already mentioned this is you can change the credentials. This is so all of this Postgres DB is running on the local Docker image, Docker instance that we'll be running right now. So if you go back to the Docker Compose, I hope my screen is visible. Yes. So you can see the Hemera indexer is essentially dependent on Postgres. So we do provide compile Postgres, which you can use and run your indexer network to chunk out the data. So this is how you configure all of these things. And once you configure the whole ACI network, the next essential step is to write out a UDF. So let's talk more about UDFs, what UDFs are, and how do you write your own UDFs. So UDFs are essentially triggers that sits on top of the Hemera ACI network or the Hemera indexer. So as we previously spoke about, right? So if you want to chunk out a specific logic, or if you want to chunk out a specific set of data, you can write your own UDF. You can run it parallelly with the indexer network. So right now I have an example wherein it mints out all the NFT mint info for a particular contract address. So let's first say I want to get out all the data for a Pudgy Penguin contract or Pudgy Penguin NFTs. So all I have to do here is first step is to mention the data class. So what essentially data class is? So data class is basically a model that you're defining for a particular for a particular data that you want to chunk out. So let's first say here I want to chunk out ERC721 data, specifically token mints. So the first things that I have is a token address that I want to fetch. Second is the token ID, block number, timestamp, and the transaction hash. There are 5 different sort of varieties that I want to fetch. So the other option is this is just something that I wanted to fetch, but you can check out the general data structure of how would a transaction look like and modify it accordingly. So you need not follow the same things, but you can modify the way you want it. So let's first say I don't want block timestamp or block number. I just want more granular details about the extra data that I'm sending across or parallelly with my 721 token. So I can add them here based on the data structure of the 721 token contract that I have, and I can start fetching things out. So this is an important and very crucial aspect, and this is called basically the domain data class that we basically specify. So next step is to specify the model. So this model is very similar to what data type model that you define on any of your software applications. So as you can see, what we're essentially doing here is we are defining the data class and we are defining the table. So this table will be created when you run the indexer network on your Postgres DB that comes binded with your Docker image. Next is you have like a set of different set of table columns that you're creating. One is with token address, and this is very similar to the data class or the data model that we have for the token mints, right? So once you do that, you can specify it and you can write your own index code here. And once this is all done, this is the token mint model structure that you have created. Final thing is to write a mint job or the UDFs that we call. So UDFs are, as we essentially spoke, are triggers, right? So we are creating a dedicated job. We are calling a few dependencies, different set of data class dependencies. Next is we're creating a token contract that we want to target. So this is a constant, and you can change it based on your own requirements. This is an NFT contract that we are tracking here right now, and you can change it. And since this is an array, you can mention multiple contracts as well. So once you do that, so once you do that, you have like when you can come to the next class, which is export ERC20 mint time job. So let's look at these 2 essential elements on our specific class. So one is our transaction element. So this essentially what it does is whenever you run the whole UDF, so it specifically looks out for all the transactions for that particular token address that you have specified right above. And next is the output type. So we have specified the output type previously in the data model. So all you have to do is specify the specify the output model right over here, which is ERC721 and that's it. Once you do that, all you have to do is run the whole network using Docker Compose up, and it should take like 5-10 minutes. And then there you go. That's it. So then it starts chunking out the data and keeps on storing out in the PostgreSDB. So I mean, it's not network binded, so you can easily access your PostgreSDB data using your any of your database viewer like Table Plus, or you can even connect it directly to your application since using the data credentials that you have provided in your Hemera ENV. So yeah, I mean that's how basic ERC721 token mint is token mint. You can do easily write a UDF for that. There are multiple UDFs that we support, and we'll be putting that in the documentations very soon on different set of UDFs that we support. But you can also check out our repository. I can just scan it through, skim through what all UDFs or what all different set of things that we have. So we also have a Uniswap support, Uniswap v3 support. So if you want to extract more data on top of Uniswap, or if you want to check out more token balance, primary token balance, you can do all of these items directly from, just switch the branch, check out the UTFs, run it on your local system, chunk out the data, and that's it. So, but if you're a data analyst, this is another angle that I wanted to add. So if you're a data analyst and if you're looking for more analysis of the data, so since all of this data is on Postgres, you can easily connect with any Power BI or Google Sheets or ClickHouse, any of those data analyst softwares and applications, and you can play along with it. So you don't have to pay for credits for the data that you're indexing or the data that you want to fetch out. So in Dune, right, you're restricted with the data, you're restricted with the play that you want to do with the data sets that's available out there. So that's one of the benefits of running your own custom ACI network. And as I said, we are currently supporting a lot of EVM chains, so you can use any of those RPCs and start running across your own ACI network. If you have any questions around this, feel free to put them in the chat. Feel free to DM us, or feel free to put up in the Telegram group that's out there for Linea dev cook off, and we'll be more than happy to assist. That's it from my side. I mean, that's a quick intro about how do you run your own UDF network, how do you run your own ACI network, and start fetching the data and start fetching more rich and user-oriented data using Hemera. So I think that's it from my side. I'll hand over to Alan to get started with Verax and more on the attestation side.
Amazing. I'll try to be as good as you, So let me share my screen. Here we go. Okay. Something a bit different now. We're going to discuss about Verax. So to start with, presentation, that's still me. You can reach me on Twitter, on Farcaster, obviously. Don't hesitate. It will be fun. Right. Verax, the definition. Verax is a protocol to publish, read, and discover on-chain attestations. Okay, that's a lot of words, but we're going to go through that. It will be fairly easy, you'll see. So first thing, Verax is community-driven. Verax is not a consensus product. It's not a Gitcoin product. It's driven by a community. We have something like 25 issuers and participants to the governance of Verax. So it means that no one is taking a decision on their own. We collaborate, we discuss, we debate, and that's super cool. We are at a point where I think we were launched 1 year ago. Now we have 6 million attestations already on chain. 1.5 million unique users did get attestations through Verax, so that's amazing. And obviously we plan on issuing many more attestations. So what is an attestation? Let's start from the start, It's basically any data that is of public interest, but on-chain. So to give you some examples, we can consider that a badge, a credential is an attestation in a way, So what are the use cases for attestations? Let's think about identity, for example. If, like me, you're tired of doing the same KYC on multiple platforms, maybe you can attest of your KYC once and for all, put it on chain, and any other platform can just check that you have this proof on chain. That could be super useful. Or if you want to prove your humanity, you've done it once on chain, it's there, then anyone can use it and knows that the address behind this attestation is a human. And if you put all this information on chain, it builds your reputation, basically. It builds who you are, what you're doing on chain, and it gives a lot more context and meaning to all your transactions in the future. In terms of security, so I want to talk about security because let's imagine you can prove that a smart contract was audited and you can put that on chain and you can read it from anywhere and basically from a wallet, for example. Can you imagine when MetaMask will be able to check the contract you're interacting with? Yes, it's been audited by this company and this one, etc. I mean, that could give a lot more trust in our ecosystem. So that's what we are aiming for. That's what we are building. We'll see how it goes, but so far, so good. Let's give another example. So attestations, we often say that, they are like style-bound NFTs, but better, much better. The idea is that NFTs were at first created to track, ownership, but as attestations can bring much more value because they bring information with them. So it means that the claim that you are putting on chain, the attestation that you are putting on chain can be verified via some logic. So the trend is to avoid, putting too much private information on chain. So why not using zero knowledge proof of information that can still be an attestation, and it can be verified. So that's super powerful. Because we have a multitude, of NFTs in the ecosystem, it's hard to find the one you are looking for, like what's the NFT I should look at to know if this person is a human, if this person has a KYC, etc., etc. So attestations are stored in one single registry. So that's the entry point to get everything that you need to know around an address. And finally, and maybe that's the most important thing, we can compose attestations. One attestation on its own brings some value, but can you imagine if you can build on top of it? Like, yes, this attestation was true 1 month ago, but now there's an update, there's something else to it. And oh yes, this contract was audited by one company, but then it was re-audited by another company. And you can build some kind of graph around an address, a contract, and everything. So that's super powerful. Right, attestations, definitions, perfect. Now let's discuss Verax, technically speaking. Verax is basically a set of smart contracts. It's an on-chain protocol, as many other, Then, because it's storing all these attestations, we need to index this data because you don't want to call the smart contracts each time you want to get an information. So we are basically using the graph to index all the information that is stored on chain. And it means that we have now two sources, the graph, the on-chain data. So to facilitate the developer's experience, we have created a TypeScript SDK. Basically, the idea is to to read access everything, and also to ease the way to add new attestations. It can be used on the backend, on front end. I mean, it's quite good. And finally, because data is cool, accessing data is cool, but displaying data, putting it out there, that's the important thing. So if you are an end user, you want to get access to what are your attestations, you need an explorer, and that's what we built. So we look into that. Basically, we have an explorer where you can see all your attestations, but basically any attestation in the ecosystem. So that's powerful, we have the most technical and low-level part, the smart contracts, and the Explorer, the UI visualization of what's on chain. Right. But now you want to attest, right? Because you want to participate in the dev cook-off with Linea. What you should do is basically 4 steps. The first one is to define the payload that will be attested. Why is that important? Because if you want to attest something, you have to know what you are attesting. That's what we call a schema. A schema is basically a description of a payload, right? Let's put it there. Now we need an entry point to Verax. So we need to be able to put data to Verax. That's a portal. It's a super small smart contract, basically, but it's your own. It will be your entry point for the registry. Finally, if you want to implement some business logic, and that's optional, if you just want to attest payloads, portal is enough. But if you want to add business logic, you can add modules in the workflow. Modules will be able to check the payload before it's really attested in the end. And finally, you will need to attest, like you will need to send the payloads to your portal and to Verax. So that's probably a web app, but that could be from a backend if you have a backend system able to push data to the registry. So we're gonna dive into a little demo. It's called proof of audit. As I said, security is kind of important in the ecosystem. So that's an example we've created. You'll get the links for the demo app, which is deployed, and the repo for the code if you want to look into it. And one last slide before we get to the demo itself. I've put a few links here if you want to participate in Verax. So basically, if you want to contribute to the project itself, you can push PRs, you can create issues, you can ping us on Discord. And if you want to build, there's a documentation. We have a list of examples actually that you can get some inspiration from. And yeah, you'll find all the links on our website. I can share the links via the chat. But in any case, you can find us pretty much everywhere, so no worries. All right, let's discuss about some demo. So as I said, the first step is to define a schema. Let's define what our attestation will look like. So here I'm using the Verax Explorer, and I'm showcasing the schema that we're going to use. The schema is called proof of audit. Didn't have much inspiration, but it does what it says. And the schema is just that, I'm going to issue an attestation with 2 fields. The first one is a commit hash that will be like the exact hash of the commit that was audited. And the second thing is the repository URL that I've just audited. Just that, simple. All right. So I have defined the schema. Now I need an entry point, to access Verax and to be able to push data to the registry. I don't want to add too much business logic to this use case. I just want to attest things. So what I did is deploy a default portal. Verax allows you to deploy the default portal, which is like the most basic portal ever. And just to show you that it's real, this one is deployed on Linea Sepolia. I'm on the testnet. You can access everything, and the code is basically just that. It's implementing the Verax abstract portal, and that's it. That's the only thing. So that's easy. Once this portal is deployed, you can play with it. And that's exactly what we're going to do. That's the web app. That's where we're going to issue attestations, basically. Yes, I'm not a designer, so it's pretty raw, but still, it works. So the first thing is I'm going to connect a wallet, as usual. blah, blah, blah. And here we go. I need 3 information to prove that I've audited smart contract. The first thing is the repo. So I'm going to put this URL, the commit hash that I just audited. I'm going to say this one. And finally, the smart contract address. And that's important, you know? It's not in the attestation schema. Like, why do I need to put that? Because an attestation is related to a subject, like the attestee in a way. So in our case, the subject is the smart contract itself. So I'm going to say that I've audited this smart contract with this exact commit hash on this repo URL. And I'm going to issue an attestation, you know? So hopefully it works, but you know, demo effect, MetaMask is popping. I can see that the attestation is going to cost around 9 cents to put this proof on chain. I'm confirming. I see that the transaction is pending. And hopefully at some point, yes, we have an attestation ID. So it means that it was attested. Let's look into it. Once again, I'm brought to the Verax Explorer, and I can see the attestation. So here I can see everything that's related to this attestation. So in details that it was attested just now. It was not revoked, you know, it's still valid. It was issued by me, that's good. The portal that was used is called proof of audit, and the subject is this address. So this address is hopefully the contract that was audited. So that's good. Trust me, it was audited. And we can see the detail of the payload. So we can see the commit hash, the repo URL. So we are basically finding everything that was attested at first. And basically, that's it, you know? So maybe let's look into the code itself for the web app. And what I want to prove here is that it's not complex to integrate with Verax. So this is basically a single component web app, you know. It's less than 200 lines. Basically, most of it is creating a form with some fields that you have to fill, and in the end, a submit button. And basically, that's it. That's the web app. Submit a payload. Let's look into what's happening. Basically, we are trying to build the attestation payload as expected by my portal. And as you can see, we have instantiated the Verax SDK. The Verax SDK is instantiated in this hook. Basically, it's super simple. I'm just saying if I'm connected on Linea Sepolia, I'm gonna instantiate the SDK on Linea Sepolia. If I'm connected to Linea mainnet, I'm gonna instantiate the SDK on mainnet. Pretty standard. Now that I have the SDK, I should be able to attest. So there's an attest function. That's a good name. And here I'm just passing the portal ID. So that's the entry point to Verax. And then I'm defining the attestation. The attestation is related to a specific schema. So that's the schema ID that we've just looked at before. I'm saying that this attestation is going to expire. It's not mandatory to say that, but I'm considering that I've audited portal and I've audited contract. It's valid for, I don't know, 1 month or something like that. Can't remember this number. And then I'm defining the subject. So what's attested? So that's basically the contract address that I've just put in the field. And finally, the payload that is attested, the commit hash, and the repo URL. And that's it. To attest a payload, I just need to do exactly that. This crafts the transaction, it sends the transaction, and then you can do whatever you want with it. So basically on my web app, I'm listening to the transaction to see when it's validated, once it's minted and everything, so I can display the attestation ID in the end. But basically that's it. The main part is instantiate the SDK, attest, giving a portal, defining an attestation, and that's it. Here you go. So it's pretty simple to start issuing attestations, as you see, from a web app. And you can definitely imagine the same code in a backend. At the end of a workflow, you want to attest that someone did something. Here you go. That's basically the same code. All right. This is obviously a naive demo. We can imagine a lot more complex use cases. So you can definitely check the examples page that we have in the documentation. We have more complex examples. This one, for example, has some business logic in the workflow to check the payload. This one has both a backend and a front end. So we are signing a payload and we are verifying the signature on chain, etc., etc. So you can find some inspiration there. And obviously, because it's a documentation, you will have everything you need to start issuing attestation. So all the steps that I've just described are there. Create and register a schema, create some modules, create a portal, and start attesting. Everything's there. And obviously, once again, if you have any question, you can ping us on Discord. We'll help you for sure. Right. That's pretty much it on my end.
Awesome. Thank you so much, Alan, for those wonderful session. One last thing that I wanted to plug in as well is, as you know, that you can create like a lot of applications using attestations and Verax. So if you want to build something on top of like an identity resolver or identity indexer kind of a thing, so you can easily do that. You can easily use Hemera, and you can use the Linea's RPC and run your own UDFs on top of it. So just a small FYI that you can easily use both of them together and build out exciting applications and DIDs and all of those aspects as well. So yeah, I think that sums up. If anybody has any questions, more than happy to take that up. Or I think, yeah, that's it then. Cool. I don't think any questions out there. But yes, thank you so much, Alan. Thank you so much for joining in. It was super amazing to have you here. I think we'll do this more often. We'll do this more sessions. And yes, once again, thank you so much. And if anybody has any questions, feel free to reach out to Alan for Verax. Feel free to reach out to me for Hemera. Once again, thank you so much. Have a very good day.
Thanks a lot for the invite.
Bye-bye.
Take care.
Thank you. Bye.